as roads.
Like a streets?
Yeah, like streets.
Sure,
And
why
then
not?
another option,
Yeah, why not?
or they could connect different trails.
Mm-hmm. You can do that. Yeah.
Maybe just to tell you like, oh, how to get to from one trail to another.
Mm-hmm.
Just got me thinking about that.
Mm-hmm. Yeah, you can always add things. What I ask you to do is like a baseline. If there's anything you think is fascinating, interests you, you can always add. Okay, so we will get started. So we talked about the J unit test last time, right? Um, so we're going to talk about we talked about design, like doing um, a burn down chart with a list of all the user cases, tasks, and then you put a weight on to each task. So you figure out how much time it's going to take you to finish each task, and then add that total, and then you know how much work is there to do, right? So now we need to start doing that, okay, for your project. So you need to break your whole project into components, into modules, into tasks, into features. Okay, of course, the smaller you divide them into, it's easier to estimate how much time will take you to finish each. Right? If you do just like one, like a big module, it's much harder to estimate. But you break it down into small components, just log in, say, um, or just to create a new account. So those are smaller components. So if you break them down like that, then you have a pretty better way of quantifying how much effort you need for each task. Then you can sum them all up. Then you know how much more work is ahead of you. And then if you set yourself a deadline, right? If you set yourself a deadline, then you will be able to figure out how many hours you need to put in every week, right? Because you know the total amount of work. And then you know you only have, say, 3 weeks to do. And then you can figure out how many hours you should spend per week. And then also you can come down to per day, like how many hours you need to finish the project. Of course, it's going to be a rough estimate, but shouldn't be too far away from the ballpark. Okay, so it should be roughly correct. So, so from now on, you should keep that chart. Okay, and then update the chart as you finish your tasks. All right. So basically, you can start to work on the project, implementing the code, but don't try to implement them all at once. Instead, try to break them down into features. Okay, then add each feature almost as if they are independent. Okay, find out what's the most fundamental one. You prioritize that and do that one first, right? For example, you need a data structure to hold a user account. So you know you need a user class, then you need another class that say we call data store to hold a user store, to hold the users, right? Then you say, all right, I'm going to just implement the login. Okay, so what you can do is you can start writing your JUnit test So you're going to put some data into the data structure into the store, and then you can test, see if you provide the correct username and password, it will return true. And if you provide the incorrect one, then you return false. Okay. You can also start to implement the GUI, because ultimately the GUI is going to be independent as well. Okay. So the best way to approach this is to think everything is independent. So this way you don't have to worry about other things. Your job right now, just make sure the login part works. Once that works, then you will say, okay, now I'm going to do another task, that is to create a new account. So what if the user does not have account? Then you say, okay, I want to create a new account, and then you're going to add to that GUI to say there's another button, say create a new account. And then when you create a new account, you're going to ask the user for information like the username, use password, um, say a string represent the profile picture. Okay, and add some other information if you like, as we talked about. And then when you create an account, the user profile information will be inserted into the data store. Okay, into the store. And then you can test that too, just make sure that it comes out once you insert it. And then how do you know? Because now you can log in and see if will return a true, right? If you provide the right username and password. So that's another feature, right? And then you want to say, um, I want to go from here to look up the history, say. Okay, so you provide a button, and then you can click on that. Will take you to look at the history of the account. So to do that, you need a data store for the history. And that one will be an instance variable attached to the user account, the user profile, right? And the history should be created, the history store should be created as you create a new user account every time. The store may be empty at the beginning, but gradually you allow people to add to it, right? To add to it. Okay, so all you provide is a data store reference variable to the user account. Now, what you can do is you can have another interface, another module, just add history, right? You can just add a history. So ask the user what the trail this was, and then how long took to finish that trail. So that kind of information, and then that will be inserted into the history store for that user. Okay, so you can just break it down like this. And then also, of course, you need a functionality to search, insert, search, update the trail information. Okay, now there's something you need to consider. That is, when you log in, if you are a regular user, then you can only uh, touch your user profile. You cannot touch the trail information, such like update the trail or delete the trail or add trail. You can only view trail, you can search. But administrators can do that. So now you need another class that is administrator, which is a special case of a user, right? It's a special case because it does everything the user can do, plus it can access, modify the trails. Okay, so how are you going to distinguish them when you store administrators? Okay, one thing you can do is when the user store can store both regular users and administrators, right? Just like have a person bag can contain instructors and students, right? So you use inheritance polymorphism to do that. Yeah. Now, once you have all the users in the user store, you have to be able to distinguish who is a regular user, who is an administrator, correct? So if someone wants to modify the trails, then you have to check that features, that variable. If the variable indicates this is a regular user, you will say no, you cannot access, modify the trail information. But if this user is an administrator, right? When you look at the first variable for that, the type, then you can allow the user, this administrator user, to touch the trails, the modify and the delete and the add. Okay, so one way to do it is you set a variable like a user type variable, and the type is a elom if you want. Okay, if you use a elom, then if elom equals say regular or just a user, then you know it's a user, and then elom equals administrator or admin, then you know is an administrator. So that's another way you can distinguish. But of course, if you don't do that, that's fine. Then you just have to use instance of. So whenever you log in, you do instance of. And if you figure out this is just instance of a regular user, then you know it's a regular user, has no privilege to modify the trails. But if you get instance of, this user is actually an admin, okay, then you allow the user to do things they're supposed to do. Okay, so in this case, then you need to have a general superclass. Okay, that's just called user, and then you have two subclasses. So this way you can distinguish them by the class. So one is like a regular, one is called admin. Okay, so this way you get instance of the user account is a regular, then you know that's a regular user. If the instance is admin, then you know it's admin user. Then in this case, you do not need elom to distinguish them, because every time you just check the type of the object. Okay, so there's the two different ways you can do it. All right, or you just don't use inheritance at all. That's just the elom. So just the user. Everybody's a user, but there's one field, one instance of field that is a elom. That field could be type. If type equals user, then that's a regular user. If type equals admin, then is an admin. So every time when people log in, you just treat as a regular user first, like a user. Then you check the type value. If it equals user, you know it's regular user. If it equals admin, then you know it's regular admin. In this case, you don't even need to do a inheritance in this case, right? Because everybody's just a user. Everything else is the same. The only reason they are admin is because they are allowed to do a few things, like access the user profile. The person could go in to delete regular users, to add users, to modify user information, and add and remove trail information, and modify, update trail information. Okay, so these are the two different approaches. Use inheritance, then use instance of. If you don't use inheritance, use an elom, then you identify different users, different type of user, I mean. Okay, the idea, of course, always try not develop everything at once. Try to develop things separately as individual tasks, So you can implement it, you can test it, even write documentation, which we're going to talk about today, and then and then before you move on to another feature, to another task. Okay, good. So you need to work on a burn down chart. You're going to put down all the weight of each task. You're going to break down, of course, the whole entire project into into smaller tasks, assign a weight to each one, like the amount of effort. You can use hours if you want to, or you can just use a number because it's always relative, right? Like this task is 2. The other task you think it has to be twice as much time, make it a 4. You don't care how how what the unit, maybe days, maybe hours, but it should be better. It should be better to actually give an hour estimate, right? This way you get a good idea how many days, how many hours, and when you can finish the project. All right, so that's the task for the next stage. All right, you can finish by Wednesday. Just the tasks, the list of the tasks, and then start to implement tasks. So you should have the tasks finished, the burn down chart, the estimate. All right, now there's something to discuss with you. We have about 6 weeks left, and I'm gonna give you all the comments back this weekend, and on the first portion of it. I got some of your, I think, who's um, the GitHub repository yesterday. Okay, so um, you can just keep on moving forward. Um, you can start to implement your project piece by piece. Okay, so the question is how long you will need to do that. We have about 6 weeks left, I think, the entire semester. Um, if you need more time, then we won't have time to do another project. If you can finish this in 2 weeks, which I think is reasonable, right? Because you just have to implement. The implementation should be easy at this point because many people already implement to begin with. Okay, so it shouldn't be that hard. Just 2, 3 data stores, a few classes, and then that's it. Okay, so I think 2 weeks is doable, but I don't know how you feel. But overall, that's a direction we want to go. So if you finish that in 2 weeks, then we have time to do something else, maybe a web related project, like a JSON, like a getting data from internet, like a RESTful service. So you can develop some apps, simple apps for the remaining part of the time of the semester. But if you feel this is a lot of work, then we may not have time to do anything substantial after this one. But in regardless, I think I would like you to finish a project, like a complete project with all the pieces, like UML diagram, JUnit test, and burn down chart, and the whole 9 yards, documentation, the whole 9 yards. So you have a complete finished project before we move on to a new thing. If we move on to a new thing. And in the meantime, I'm going to lecture on other topics like a multi-threading, design patterns. So um, so you can work on this project or another project during that time. Should we shoot for 2 weeks? Should we shoot for 2 weeks? Yeah. So you can just move forward now. Start coding when you're ready. Break it down into small things. Those are things are not they're not more complicated than our work did in 180, 218, and 148. If you think about it, the 3 data stores is not more complicated than what we did in 218. They're not, right? Just think of them as 3 bag classes, except this time the bag is not an array. Okay, instead it's like a tree sets or linked list, and so on and so forth, right? Now this time you're going to use stream, so this way you can minimize the amount of code you have to write. Remember the stream, right? So I think this is not a lot of work. It's not a lot of work. Right? Should we do that? Shoot it for 2 weeks. That means next Wednesday, the Wednesday after next Wednesday. So 2 weeks from today, in other words. Okay. So as you finish things, just push onto the GitHub. So every time you achieve something, so you have a burn down chart, great. Put it on the GitHub, right? Put them into the project, into a folder, then push the whole folder up into the GitHub. So when I check your stuff, I just go to project folder, everything's there. Have a folder called UML diagrams. Have a folder for your burn down chart, right? So this way I can go to the project folder and look up things you submitted. And then once you're done, you have time, just go ahead and try to code it. You can sit down, try to code a day, maybe 2 days, it should get done. Right? Because you have a pretty good idea what is needed. Right? Now the only part that's variable is the GUI part. Right? The GUI part, you can just do the regular GUI like we did before. Okay, just JavaFX. But you can also use Scene Builder. Okay, I would recommend Scene Builder if you don't mind. You have the choice to do either one, but I think it's a good opportunity to try Scene Builder. So this way, if you never tried before, so this is something you can learn quite a bit. Because the way we use Scene Builder is the same as the way we build mobile apps. They're very similar. In both cases, we use something like a framework. Okay, so in the framework, we can drag and drop to build a GUI. We can we divide our code into this thing called an MVC model view controller design pattern, MVC model view controller. So that turns out to be the current most popular approach in developing applications in the industry. Okay, so if you don't mind, you may want to try that if you haven't tried the Scene Builder, which we're going to go over today. Okay, so can get you started. And if you want to try it, that's great, because it's so much similar to things you're going to do in the future in your career. Say you want to do mobile apps, you want to do web apps, they all come with a framework you can just use. Do you understand? So I think it would be good opportunity to try that. Okay, to try that if you never tried it before. And this is a new way of thinking about things. So by trying it, you may get used to this new idea, like breaking code into model, view, controller. And then the sim builder will force you to think that way. And all the other frameworks people use in the industry, like a Microsoft Visual Studio, probably has like a half of the market, right? Developing applications, both desktop or mobile. They they are just like that. And then all the Android app development, Apple, like an iOS app development, they all use this kind of approach. So I think it's a good idea to get to know it a little bit. Okay, but if you feel like you don't have the time to learn anything new, then you want to use the traditional Java flags, like what people usually do in 148. That's fine too. You understand? Yeah. Okay. Um, do you have any questions? Any questions? No questions, Yardio? I was expecting questions from you.
No questions at the moment. At the
Okay.
moment, of course.
All right. That's unusual. Okay, good. So we're going to start talking about documentation. Okay. Now, Java code uh, should professionally, they should come with documentation. So someone read the Java code to understand how to use your program. And they understand what each class does, and also what each method does, and who did it, when it was done, what version this is. Okay, if there's a problem, who should contact? Okay, now of course you can write all those things into your source code as regular comments. But if you do that, then when people try to read about your program, they have to open your source code to read it, right? They have to read the comments. This is annoying for people who have no idea about Java, but they may still want to use your program, right? And so we should create another mechanism, and we're going to use that to store the documentation. So someone can just open that document to read about your program without touching your source code, right? And turns out now the way to do it is we create a web site or pages. It's just like when we do Java doc, you will see the web pages. I give you an example. So if I do say say string, so I just go Java doc. Okay, so I'm gonna show you on my screen. You see, I did search for string Java doc, and you can see there is a documentation for standard edition 7. This is for 8. This is for 11, right? And that's the latest one. Okay, if I just look at the 8, and you notice is a website with the web pages. Okay, so if I click on the link, that will take you to a page. Okay, the page is the main page for the string
Professor,
document.
I don't know if we are
Oh,
showing something up to us.
no, I wasn't. Okay, so you're probably familiar with this. So basically, went to did a Google search. I searched string Java doc. Okay, so what I did was, sorry, string Java doc, okay, and the string Java documentation. I hit enter, and it gives you a bunch of links. This one is for Java 7. This is an older version. This one is 8, more recent. This one is 11, okay, even more recent. Then there's no more changes. There's no more changes to the string. Okay, so you see there's a link. It shows you where that web page is stored. It's stored on this computer. Okay, it's Oracle's companies. It's a computer that stores. Usually we call this a computer host. The host is docs. Believe it or not, usually this is the computer name or web server name. The name's called docs, or at least is a nickname of that computer. And then this is the DNS address, domain name service address. It identifies this computer on the internet. So this is identified is a computer in the company for Oracle. Okay, and then on that computer there's a folder called Java SE. Okay, on that computer there's a folder / the Java SE, and then under that, in that folder, there's another folder /8. In the 8 folder, there's another folder called docs. In there, there's an API folder. In there, there's a Java folder. In there, there's a LAN folder. You go all the way down to the last one, string.html. Right? So that is the page. Just stored in all the different folders and all the way on this computer. So when we click on this, it will take us to that page. Okay, so click on this. That's where the page is located. You see this on top. Okay. Now over here, explain. Essentially, this is the web page, right? You can see that. There's a whole bunch of links. You see this? Okay. Now here is the class called a string. That's the name of the class. You can see that's the class. Okay. And it also tells you where the class, which library the class is in. It's called java.lang. Lang stands for language. That's where the library is. Okay. Now that library is always imported in every Java program by default. That's why we never have to import a string, because that's always import. The library is always imported. Okay, and then it will tells you what this what is the interfaces. Now, of course, it tells you the superclass is an object, like every class. Okay, superclass of string class is object. Object is also a class in the library Java Lang, so we don't have to import that either. Then underneath it, you see all implemented interfaces. Okay, so these are the interfaces this string class implements. So string implements serializable, string implements char sequence, string implements comparable. That's why you can compare strings. Remember when we did the sort, right? Search. We need to be able to identify strings, right? To see which one's smaller, which one's bigger, to sort them. Remember, in order to do that, you need a comparable. So it does implement comparable. And there's a method. Comparable is a functional interface. It has a method in there. Anyone remember the name of the method in the comparable interface? Anybody remember?
Compared to?
Compare to, exactly. Compare to. So if you implement that comparable, you have to implement a compare to method. Compare to method returns an integer that allows you to specify if you want sort your object in what way? In what order? Ascending, descending. Okay, so in this case, it's a string. So basically, you just sort the string. By default, is a ascending order. Okay, the smaller one comes out first, and then the bigger one that goes behind it. Okay, and now string also notice is a final class. You see that? What does that mean? Do you remember what a final means?
You can't change it.
No, you cannot change anyway because it's a Java class. You cannot go in there to change. What does a final mean? When you have a final class,
You can only assign it once, or you can only use it once.
no, you can use final many times. When you have a class that's a final, do you know what that means?
It means that the value of that is set.
Well, this is a variable, but this is not a variable. This is a class. When you have a final variable, yes, you cannot change the content, change the value of the variable. Whatever variable you give it to it, and there's going to be that variable. Going to be that value. You cannot change the value anymore. That's a final variable indeed, like a pi, math.pi. But final class means this class cannot be used as a superclass. Okay, so no other class can extend this class. Okay, so this is the dead end. Good. So that's what a final means. So you never seen anybody extend string. That's why you cannot extend string because it's a final. Okay. Do you remember what a serializer was used for? You said
A
before.
specific identification kind of for that instance.
What is it specifically for? It's actually an empty interface. There's nothing in it.
For saving. For saving.
What?
It's
For what?
When you write it to the disk.
Yes. Right. Because when you have a class, right? Class meant to build objects, correct? So the object holds data, correct? Class doesn't really hold data. It's the object holds data, right? Now the object holds data, and then when you try to save the object onto the hard drive, the hard drives, current hard drives are built in such a way you can only save data in sequence, like a byte by byte, bit by bit, byte by byte. So that's why it's called a USB, Universal Serial Port, right? So current hard drives can only accept data in sequence. In other words, you cannot push all your object, the entire object at once into the hard drive. You have to break the object down into a sequence, organize the data in a sequence, like a two-dimensional sequence, and then you can feed them into the hard drive because that's the limitation, that's the constraint of our hard drive. So in order to save any object onto the hard drive, okay, you have to make sure that class, whatever the object is built from, implement serializable. So this will indicate to Java that this object will need to be break it down into two-dimensional sequence. So then after that, that's the condition. So after that, the object can be saved into the hard drive. Otherwise, you can't. Okay, so that's exactly what a serializable is. Okay, now the comparable is so you can that, right? You can compare, you can sort, you can search. So because of that, char sequence, because string is never stored as a string. String is stored of an array of characters. Okay, so this is another interface in Java land that is a common that string basically just an array of characters. Now array, the characters made of ASCII code, not ASCII code, I mean Unicode, because in Java you could store not just English, you could store other languages as well, so that it uses Unicode. Okay, so if you have one character is 2 bytes, 4 character will be 8 bytes, right? Each Unicode in Java, specifically in Java, is 2 bytes. Okay. All right. So see, is the character strings. All right. So basically, that tells you the class, give you a lot of explanation, comments, and then you have a version. See the version number? Since there's a version number, JDK 1.0. So that tells you when this is introduced. In JDK 1.0, that's the first version of JDK. JDK stands for Java Development Kit. Java Development Kit. Okay, that's the first JDK for people to develop Java program. And now that's the when it's introduced. Now see also like a reference to these different classes. So those are links. You notice you can click on them. They're clickable. You see this? They're all clickable. Okay. So you notice that's like a web page, right? That's familiar. That's a web page because a lot of things you can click. Okay. Now there's also, you look at the format, there's different font, different color, right? Different font size. So now you have a field summary section. Under there, you have a fields. Fields are like instance variables. In this case, you have a static one. See static, comparator. Okay, there's a data type. Generic, so you're holding string. Okay, this is static. You see that? Now this is the field name. Because it's a static. Okay, so so that means these you can only have one value, one instance. Static means one instance. Final means you cannot change. Static means the whole entire string class, as well as all its objects, share the same case insensitive order. Okay, so that's what. So comparator that orders string object as a by comparator to ignore case. So in other words, you can do ignore the case. So that's the variable name. And then you have a constructor summary. See the constructor. Then you have different kinds of constructors. They're all called overloaded constructors. You see, one constructor, no argument. Okay, and then you have one with an array for bytes, array of bytes and a char set, and that specify how the bytes are organized, because there are different ways of organize the bytes. So that's a char set. It's user specified way of organizing it. And then you have all kinds of constructors. Okay, and you can take a string builder in there as well to build a string object. Okay, then you have a summary of methods, and this is just a simple version. See, that's what it returns. This is the method's name. This is the parameter. Okay, then it explains what this does. Explains what this method does. It returns the char, which is this one, value at the specified index, at this index. Okay, so you have a string, so char at 1, that will return the second character. Char at 0 will return the first character, right? So that's, so in any event, so the whole bunch of methods that are there for the string class, but each one of them has a link. You see, chart add, and this is the summary version. And if you click this, it will take you to a detailed version. See, the detailed version specifies all the details. Okay, what this does. See what this does, and where it's specified by chart add in interface. So the chart sequence that has that method. That's why you have to implement chart sequence, because that forces you to implement the chart add method. Okay, and then you have a parameter. See, there's a parameter index. So that's a parameter, right? That explains what it means. The index of the chart value. Okay, the index of the chart value you want to return. And then return the chart value at the specified index of the string. So if it's a hello dot chart add 1 will return E. That's the second character of a hello. Okay, so that's what it returns. And this explains to you what kind of exception it might throw. That means you might have to catch, and it turns this index out of bounds exception. So if the index goes negative or not less than the length of the string, then you will throw index out of bounds. So if you are index that's bigger than the length of the string, of course you can throw an index out, array index out of bounds. Okay, so that's a specific detailed description of the char add method. Okay, so this is another one. This is empty, returns true if and only if length is 0. Returns true if length equals 0, otherwise false. Since when? Since 1.6. Okay, so that is documentation. Okay, so of course you need to get used to this, because most time you learn things by reading documentation. Okay, you learn new things by reading documentation. So when you write your own program, okay, if you write it in the professional level, then you should also provide such documentation. So someone else could read your documentation and figure out what each method does, what is the parameter supposed to be, what interface you use, what exceptions you may throw, and when you did it, who did it, so on and so forth. Now, of course, so far we haven't seen like who did it, the author. Okay, but in your application, most likely you should specify who did the job. All right, so basically today we're going to talk about how to generate this, okay, for your own program. Yes, Ryan.
So we essentially we would be doing this for all of our methods, but we wouldn't be doing this for like getters and setters, right?
Well, you don't, but also you don't automatically always write getter setters, right? When you develop software, never develop anything that's not needed. So just because when we took 148, we use getter setters all the time, it doesn't mean they are part of this class. Okay, so a lot of times you actually want to protect the data, you don't want to provide getter setters. Okay, so don't automatically generate. Now, of course, if you want to fully document your project, you should cover every single method your class has. Okay, that just that's just the way it is. Okay, but since we are just doing this for the class, so I don't want you to spend too much time trying to document, but I just want you to know how to document it. So I would ask you to document a few major methods Okay, so then you have a bunch of web pages, and that be part of your project. So if I want to read your project, I can go to that web page just like what I did here, and I can view it with a browser. I'll show you how to do it. Okay. All right.
So generate them for a few classes.
Yeah, a few classes, a few methods, the major ones, just so you know how they're done. But we don't have enough time to do everything, to document everything, because a lot of things takes time to do. Okay, good enough. So the idea is you know how to do it. Idea is you know what is expected in workplace. Okay, that's how you separate the people who are professional from the hackers. Hackers just want to get things done, don't need to worry about documentation and then support or any kind of history record keeping. Okay, so if you want to be a professional, then you need to present that way. You have to provide all the evidence to demonstrate that you know all the different aspects of things. Okay, so I'm going to write a simple class and then we'll show you how that's done. Okay, so I'm generator. I'm going to call this Java doc, Java doc tutorial. Okay, so that's the class, Java doc tutorial. And then in here, I'm going to write a class, right? So first of all, I'm going to create a package, okay? And then I'm going to call this package with something, with a name that's kind of meaningful, okay? So I could call this temperature, temperature conversion. So the code itself is meaningless. The whole idea is how to document it, okay? So temperature conversion. So instead of using P1, P2, those makes no sense in this context, right? So things should be, everything you put down should tell something meaningful, right? So this is a package called temperature conversion, and then inside this package, then you can have a class. Okay, the class we're gonna call temperature conversion. Now this time it's a capital T because it's a class. All right, it's a class. Okay, now because it's a class, so the name the class should be more like a nouns, not verbs. Okay, so keep that in mind, right? So now we're gonna say, okay, let's do, in this case, I do a main, okay? So this way we have something complete. Okay, so now under below package, that's where you're gonna generate the documentation. That's where you write your documentation. Okay, so we know there are different ways to use a comment, right? When we use this, that's called inline comment. It's called inline comment, right? So that means starting from the forward slashes all the way to the end of the line is considered to be comment. So anything you write here is considered to be comment all the way to the end of the line, right? Until you hit enter, then there's no longer comment, right? So that's called inline. So it only does one line at a time. Okay. So another one is just the forward slash, one star, and then hit enter. And then you can write anything you like, and that's called the block comment. Okay. And then you can write multiple lines. Okay, just hit enter. It automatically creates this green block which you can describe things you want to describe. Okay, now neither of this are used to generate the Java doc, the web page I was showing you. Neither of this. So these two are used for the programmer, the developer, to make notes. It's not meant for users. It's meant for programmers themselves. So you want to make a note, say, oh, this is my to-do list. I finished this feature. I'm going to add that. And this method is not working. There's a bug in this method. The return type should be different. Should be changed from integer to double. So those are things that you want to kind of serve as a reminder or record for yourself. Okay, not to be used to generate a web page for other people to see, for the user to see. User has no business here. Okay, now the difference between the two is the inline one does only one line. So you only have one line to do, just use inline. But if you have a lot of things to say, you use a broad comment. Okay, but regardless, both are not recorded in the Java doc. Okay, so you know that, right? So I'm going to get rid of those. So you use those, but you don't use them to expect that we'll get into the web page or web pages. Okay, it's only meant for you to keep a record, set up a reminder, this kind of purpose. Okay. Now the real purpose is you can do something like this. You can do something like 1/ like last time. Okay, let me put a blank line there. One. Now you put a 2 stars. Okay, 2 stars, and then hit enter. Now you see that is called. Let me make a note here. This is called Java doc comment. A dark comment. That means 1/2 stars, or anything more than 2 stars. It's fine, but at least the 2 stars. And then you end with a 1 star or forward slash. Then whatever you do here, you see the color is like a bluish. Last time it was green, right? This is the bluish. So these were going to go on to the web pages we're going to build. So whatever you write here are going to be incorporated into the web pages you saw before, similar to that. Okay, so for example, you would say something like this: the temperature conversion Java application. Okay, so blah blah blah, print a table. Then you can hit enter. Converting Celsius to Fahrenheit degrees. Basically, you write some comment. That's the part about what the purpose of the class. So that explains what's the purpose of the class. Now, this is a simple case, but you could be longer. Okay. Now it automatically added, when I do a Java doc comment, automatically add the author. So it's an annotation called add author, then followed by what Eclipse perceived to be your user name when you log into the computer. Okay, so if you don't want to use that, that's fine. You can use John Doe, whatever name you can type. So that means this entry is going to be incorporated into the website, indicating who the author of this class is. Okay, so notice we use the annotation add author, right? Okay, now I can also have other annotation like add. Okay, C means the reference. Okay, like other files that reference relate to this one, or you can provide a web page that provides some extra information about this. So this provides a link people can click on, where you can explain further what this class is about. So basically, you can get a link in there. So you put it down. A, that's the anchor, that's the HTML, right? The anchor. And then you say href, that's where you're going to follow by the link. Okay, by the link. The link is, in our case, I can just, we can put anything you want. Just basically with, if you want to show the source code, you can say in here, you can say src, so src dash temperature conversion, that's a package name, dash temperature dot temperature conversion dot java. Okay, so that specifies where the source code is. Okay, the source code is relative to the web page's location, because the web page we're going to create is supposed to be in the project folder somewhere. So I don't really know. I haven't decided yet. So I just know I'm going to indicate where the source code is. So when somebody click on that, on the link, then you're going to show that file, which is this file. Because remember, all this is built into a web page, and the source code is not there. By doing this, you provide a link to the source code. So whatever we're writing here are going to be incorporated into that web page we saw earlier. Okay, so and then after that, you can just say after that, and you can just say you close it. Then you can say Java. No, let me say close it first. Okay, that's so you close it. Then you can say Java source code. So that thing will have a line underneath it, but not underneath it. It will change the color blue. So it shows this is a link. So when people click on this, then this will be displayed. The file will be displayed in this location. Will be displayed. Okay. So the Java source code will become a link. Okay. So that's another annotation. And then you can continue to put more information. You can say, I don't know, whatever you want to say. You can say, your, I don't know, where you want to put it. It's like Sunny Suffolk .edu. You can provide whatever you want to provide. Most importantly, then, is you have to close that tag. But excuse me, you can write in multiple lines. It doesn't matter. So that becomes a link. That's a tag, anchor tag. That's a ref that shows if you click on this, this is going to be displayed. You close that by using angle bracket /a. Okay, to close that tag. So that's C. And then you can also have things like add version to the version. The version, you could say something like a v1.0, the first version. or you can say something like November 4th, 2020. So you can put a version number, or you can just put the date. Then since will show up. Since then, that will show up. Okay, we saw since before, right? So so that's it. So that's before the class. You write this comment, Java comment, before the class. Okay. Now we have the class. Now then, before the method, we have to do something similar. Okay, do something similar. So Eclipse detects that this is before the method. So it asks you see if you want to explain what arg is about. Okay, see, that's a parameter, you see? Okay, so we usually don't have to explain the args, but if you have other parameters before, like index last time for the char add, then you have to explain. That's the index of the character returned, right? So in addition, you can say the main method, whatever you want to say, print a table. So you explain what the method does, okay? Prints a table, a Celsius to Fahrenheit conversion table, the bounds, for example. So explain of the table ranges from -50 Celsius to +50 Celsius in 10 degrees. In 10 degrees, we'll just say 10-degree increment. So that explains what the main method does. And then the param arg, that's not used. So you can just say, not used. Just say the string argument, string array argument args are is not used. So put into parentheses if you want. Okay, so it just explains what this is, so you're not using it. Okay, so that explains what this method does. And then when you write the method, okay, then you're gonna have to explain things. For example, you're going to explain. Okay, you just have to write the method now because we already explained what it is, right? So we're gonna say final double, and then because it's the final, so we say table begin equals, that's a variable, equals -50.0, and then final double table end at 50.0. Okay, so we have two variables. They're both final. So these are the cases that the variables cannot be changed because they're final. Okay, now at this stage of your career, you need to be careful. So when you write the code, right, if this is a final variable, it's supposed to be a final variable. Okay, you should use the final. Don't just say, oh, I need a variable, let me write it. Then you have to think about, is it a final? Do I want people to be able to change it, or I don't? If you don't, then you have to put a final. You should put a final. Okay, although it's not necessary, but at least you know you don't want people to be able to change it, then you put a final. Then you know what that means, right? It means that this variable cannot be changed. -50, +50 cannot be changed. That's what a final means. And also, if it's a final, you make it all letters capital for the variable name. And then you don't use a camel case, obviously. Then use an underscore to connect the words. Okay, so that's the variables. So now we say if, then we have another one. We have a final, double, and table step. Okay, that's a 10 degrees, remember? Increment. Okay, and then I have two other ones. It looks better, so make it look nice. So table, Celsius, and double, and then Fahrenheit. Okay. So now I just kind of do some displaying. I say this out temperature conversion. Okay, that's one line, and then this out. Then I put some dashes, and then this out. I put some Celsius, and then maybe I put some space, and then I'm gonna say Fahrenheit. Okay. So now I just do a loop for Celsius equals table underscore begin. Remember that begin? Okay. Then Celsius less equals table end. See, I'm avoiding those magical numbers. Notice that? So I'm not giving you some like a 10 or 50, -50, because I define them clearly here what they are. Then when I actually write the code, I just don't put this as -50. I don't put this as a +50. Instead, I use variable name or names, right? And then eventually that is just a step. Then we say Celsius, and then plus equals table underscore step. Okay, so so when you write a code, table, I write wrong, table step. Okay, so this avoids the magical numbers. Okay, so that shows the quality of the work. And then you will say something like just the calculation. So Fahrenheit equals Celsius to Fahrenheit, and then Celsius. So I put a Celsius into the method, put a Celsius to Fahrenheit, and return Fahrenheit. Okay, and then obviously I need to write that, so I go create a method, write that. Okay, so that's the method, and I can even make it a public so people can use if they want to use it. So public, okay, and then here I'm going to continue here. I'm going to say sys out. Okay, so I'm going to sys out, then percentage 6.2 FC. That's the format. Celsius. You know this, right? This is the printf format. Okay, so you print that line, and then you're gonna print the Fahrenheit. So sys out. I'm not changing the line yet, so I'm still on the same line when I display. And this format is percentage 14.2 F F. Now I'll change the line back as N, and then I put a comma here, then Fahrenheit. Okay, so I do print F. Okay, so once I'm done, I'm just going to print a blank line. Okay, after the for loop. So sys out. Excuse me. So I'm going to put a blank line there. Okay, so that's the main method. Obviously, you should usually put it into somewhere else, but just for argument, for demonstration, we put them inside the main. Now here is the Celsius to Fahrenheit. That's a new method, so you need to have a comment for that. So you're gonna say 2 stars, hit enter, then tells you Celsius. Then you explain first what this method is about. So you can say convert a temperature from Celsius to degrees to Fahrenheit degrees. So that's the purpose. And then then you have the Celsius as index. Then you can say what this is about. You say a temperature in Celsius degrees. Okay, and then you can also say the return. What returns? Return. I want to explain here that the temperature. Okay, return temperature Celsius converted to Fahrenheit. So basically just explain what each one does. And then this time I'm also going to have another one. It's called throws. Okay. There's a throws. I should have a throws. I didn't say throws. So throws. That's another annotation. So it tells you what it throws. It throws Java, len, illegal, argument, exception. Okay. All right. So it throws that. Then when you write it, then you're gonna write it this way. You're gonna say final, double. You're gonna say minimum Celsius equals negative 273.16 degrees. So that is the minimum degree, right? Because temperature, you cannot have a temperature lower than that. That's the lowest temperature possible. Okay, otherwise the electrons, atoms will be frozen. So, so in terms of temperature, that's the lowest possible temperature. Okay, so then you say if Celsius is less than minimum. Again, I'm avoiding the actual number. Okay, if that's the case, then I say throw. So somebody try to convert a number that's smaller than its value. You're gonna throw a illegal argument exception, then argument, and then you say plus Celsius plus is too small, too low, too small. Okay, is too small. Okay, so that is a message. And put this, and we just say return. So what we're going to return is we're going to return 9.0 divided by 5.0, and then you multiply by Celsius value, and then plus 32. So that's the calculation of conversion. Okay, so now we can see if the program works. Okay, so it will show you something like that. Okay, so 0 is 32, and the negative 50 is of negative 58 Celsius to Fahrenheit. Okay, so the program works. That's not important. Now, important is we're gonna now convert this into a web page. Okay, so what we do is we'll go to project. I think, yeah, generate Java doc. Okay, so you go to generate the Java doc. and then you say java comment. So that's the JDK I use. That's in my program file Java. So otherwise you're gonna have to figure it out. Okay, so the way to do it is configure, and then you go look for your JDK. Usually, if you're Windows, you have the C drive, and the C drive with program files. Then you go to Java, go to JDK. In the JDK, you have a bin. In the bin, you should have Java doc. There you go. See, Java doc. So you open. So you're gonna use that one to generate the web pages. In other words, so this is the program that will help you to generate the Java, the web page. Okay, good. Now, once you have that, then you're going to destination where you want to generate it. Okay, where you want to put it, and you put in the same project tutorial under a folder called doc. That's fine. Okay, so for your project, you can do the same. You can do the same. So when I look for your web pages, I just go to that place to look. Don't save it on your C drive somewhere else outside of your project, because I won't be able to see it. It has to be located somewhere, I can see it, right? The best place in the project so I can see it, because you always submit your project. Okay, and then you can just say, now, what kind of methods you want to generate Java doc? Remember, initially I had this method called private, right? If I select the public, then that means the private one won't show up on the web page. Okay, because the private methods are internal to the class. You may not want people to see the internal structure of the class. So if there's a private method, you don't want to show, then you just check public, then those will not show. Okay, but right now, since I made it public, then but all this will show as well onto the web page. Okay, so you just say finish. Okay, do you want to update Java doc location for Java doc tutorial with the chosen destination? Do you want to update? No. Because no, not to all. So now it's trying to generate it. You give you something, even some error, some warning. Even I think it works. I always have that, but never really had a trouble. Okay, so supposedly it worked. So let's go to the location, and you see now there's a folder doc. Okay, and you open the doc. You see there's a bunch of folders. Files, right? The most important one is index files. Okay, so you go to the index one and see those are index files, and then you can click on index1.html, and you can just click on that, and you see the class we wrote, cells to different. That's a method, and let me see. I should have a I should have an index one, just show the first page. There you go. That's the first page. Okay, let me close this for now. Just go to the temperature conversion folder. This index page. You go to that page. That shows you the class page. So the class is temperature conversion. Description is what I wrote before. And then this is the package. Package is temperature conversion. And then and then you can click on the class, and it will take you to the details, right? It tells you the version. You see the version 1.0, November 4th, 2020, author, see also, that's a link. Okay, when you click on this, it supposedly will take you to the source code file, but you don't have to, right? There's no need to do. But if you do want to, then yeah, just to make sure how is that related to the SRC. So you may need to change the path. So it's pointing to this file. pointing to this one, pointing to this one, the main method, or yeah, the main method. So pointing to this one, that's the main dot. No, temperature conversion one. I mean, it's this one. The .java. That's the Java file. Okay, remember this place I said the C also. That's the place. So when I click on this, it's not going nowhere because there's no file there. But you do know there's a link. Now constructor is the default one. Okay, temperature conversion. I didn't write anything about it, so it's a default constructor. The methods I have Celsius to Fahrenheit. That's a static returns a double. There's a main method returns a void, and then there's a summary. So Celsius to Fahrenheit description, convert a temperature from Celsius degrees to Fahrenheit degrees. The main method prints a Celsius to Fahrenheit conversion table. The bounds of the table range from negative 50 Celsius to positive 50 Celsius in 10 degrees increments. So these are all just the summary. Now, if you want to look at the details, you can click on whatever you want, say this one, and it gives you detail. And that tells you the parameter is not used, tells you this is what it does. And then if you look at the other one, is this method, what it does, converts, as a header, converts temperature from Celsius degree to Fahrenheit degree. Parameter A, Celsius is the temperature in Celsius degrees, returns the temperature Celsius converted to Fahrenheit, throws this exception. So it's pretty straightforward. Okay, so now if somebody wants to know about your program, right, they can just go to this doc and find that index page, remember that index page, and then go from there and see everything. Or you can copy all this, the whole web page or website, put it onto another web server, and then people can go there to look it up. So that is documentation. Let's go to Java doc. Right, so it's pretty straightforward because Java doc provides this utility with Java. It's a part of a JDK, right? To generate this standard format. This is the same one we saw earlier, right? It's all standard color, standard font, standard size. So we don't have to know how to do web programming. We can just type the commands in Java doc comment on your program, and then Java doc program will convert that into pages in this organized way. Okay, so pretty straightforward. Any questions? All right, no questions. All right, so you're going to do a few, okay, whatever you feel comfortable, 2 or 3, whatever you want to do. And so you try this, okay? So this way you make your program somewhat complete because you know you have those aspects included, even though you didn't write all of them, but this is something. But of course, if you have time, you can do more, right? But do 2 or 3, be good enough. So you know how to do it once, at least. At work, you're paid to do the job. So you can take your time and do every single one. Right? Okay, so that's the point. And then officially, professionally, every program you write, you should document it. So when you develop anything for any people in a professional capacity, so somebody contract you, somebody pay you, somebody hire you to do work. If you think it will take you an hour to do the coding, add 2 hours because you need the documentation, you need to write the JUnit test, you need to do all the other things that are not obvious but are necessary, but they are necessary. So you want to budget more time. It's just like you have a licensed plumber. When they do things, they have to follow protocols supposedly, and they charge you more money. Then their work is more trustworthy, hopefully, right? So that's professional. It's like anyone who wants to become a professional, there are protocols, there are rules you have to follow. That's why they are so expensive, because they are professional. So if you write a code, don't overlook this. Imagine you work for someone, for a company, your program has all those things completed, right? So if one day you leave the company, then whoever take over can have an easy job, because if they want to change your method, change the program, refactor it, you already have all the JUnit tests. If they want to understand what you did in this program, they can read the Java doc and they can trace, find out what you did and when you did it and for what reason. So you can explain carefully. So it's not like you go to workplace and you took a job and you look at people's code, you have no idea. There's no reference. That's bad. You can imagine that, right? If it's application, hundreds, thousands of lines of code, no documentation. That would drive everybody crazy. Okay. Makes sense, right? So that's just the way it is. If you want to show people you're a professional, then you should do this. Okay, for our purpose, again, just do once or twice. And so this way, a couple of times, so this way you know how to do it. That's all. Any questions? Okay, if there are no questions, I'm going to start an entirely new topic. I'm going to close this. Close this, okay? And I'm going to generate a new project. Now, this time I'm going to generate a project called, because I think this is useful for you to, for 5 minutes, for you to prepare you to do the coding part if you want to during the weekend. So let's say we're going to do a project. I'm going to call this a project Scene Builder. Actually, it's one, I think. Scene Builder tutorial. Okay, so that's your hiking project. Okay, and then you decide you want to go use Scene Builder. Right, so you can just say, I don't know if you have to do this. So if you want to add a library, remember the user library. You can add a user library for the Java facts. Okay, so go to class library, class path, add library, add a user library. So I have my FX library. Okay, you know what that is, right? So you add that. Okay, and then you say I pick my JDK, which is JRE, which is a 13. I should have a 14 or 15. So I finish. Okay, so I don't need a module. So now I have a project, right? It has my FX library included. And now I'm going to have packages. Okay, so the way I organize packages is I have one package called app. That's where the main method is going to be. Okay, that's the main method is going to be. And then I have another package. I'm going to call this one model. That's all these old Java objects are, like Java code, like all the classes we used to write, like the data store, the user trails, all these classes we use to create objects to hold data. That's why we call it model. Model is another word for data. Okay, so that model will be a place holding all this we call POJOs, plain old Java objects. All right, now third package, I'm going to call this view. So all the GUI stuff go into this package. Okay, so you separate them. So that finally we have another one. It's called controller. Okay, so the controller is where you're connecting your model and the view. Is like a middleman. So we're gonna have to explain this another time. But right now, if you want to do it, you can have this. So now here's where our main method is in the app, right? So go to new, go to class. So I'm gonna call this main method main class. You can call it app class, it doesn't really matter. So you want to go to main class or app class, doesn't matter. Okay, so now you need the main in there, see? Okay, so that's that. And now I want to say, because I'm going to use a GUI, right? So I'm going to say extends application. Okay, extends application. Now, if I move my cursor over here, you know this JavaFX. Remember I added the FX library because of that. So you recognize JavaFX application. So that's the one I want. And then I go to main, add unimplemented method. That's the start method, right? That's where I'm going to write my code. But here I'm going to just say launch arcs, right? Okay. Now here is where you're going to write your code, right? Your code if you want to. So the code is made of a component that indicates where the view is. Okay, so I'm gonna do something like parent root. That's the root container. That's one you put on the scene. In other words, root and equals fxml loader loader.load. Then you're gonna say something like a get class. This one I tend to forget. Get class, get resource, and then once you get a resource, you're gonna put down the the view file, the fxml file. So you put that into double quotes. So that's a string. So mine is say app. Inside there I have a main. That's a main class. No, I don't want to put an app. I put a view. I'm sorry. View. I can say main. That's inside the view. I have a file called fxml. Okay, so that's identifies the GUI component, the view. See, it's inside the view package. Okay, I think I might have to do. I'm not sure. So you have to test it out whether you need to put SRC or not. I don't remember. I don't think I need to do it. So that's good enough. So then you put it down. Import FXML loader at that, and then you have get a class. This is correct. Load. Okay, parent is, I know I can import a parent JavaFX as well. Okay, there you go. So that's how you load your view into your application. Okay, so this allows the view to be self-contained, created somewhere else in a different package even, right? That's what we want to do. Now, once we have that, then we have a scene. Scene, we're gonna say scene equals new scene. Okay, then we're gonna put down the root, and then we put it down the size of the scene, 400 by 400, right? So we import the scene. Now, there's another one you may want to use. You put a scene dot get style sheets. That's a CSS file. Okay, that's where you're going to specify CSS file. Style sheets dot add, and then inside there you say get class. That's a class method. Get a class. Dot get resource, and then resource you say the same thing. that's where you want to put this file. So let me see where I'm going to put this. I'm going to put it, say, inside of view slash applic. I can say main dot CSS or whatever you want to put it. So that will be the CSS file. Depending on where you put it and then and what to name it, you're gonna have to specify. So add style sheets, add why I have no get class. I must have a mistake somewhere. Get class, get resource, view. Oh, okay. I have to add that dot to external form. To external form. Now it's good. Let me minimize this. So this allows you to introduce CSS. Okay, so you can control the feel and the look of your file, or of your GUI. And now finally, I just do, this is a stage, right? So I'm gonna call this primary stage. So now I'm gonna say primary stage dot set scene. Then I put down the scene, and then primary stage dot show. Okay. So no, just show. Okay, so that's that's your main class. Okay, so that's now because this file may or may not exist, so you may have to use a try catch, but if you know it's there, you don't have to worry about it. Okay, so that's that. Now go back to the project explorer. Now we're gonna create a view. So go to view package, right click, and then you go to new. You go to other. You see the other, and look for new fxml document. So now that's where you're going to set the view. New fxml document. And then that's in the package view. You give it a name. So this is going to be for the main view. say that's your main view. So main dot, just the main, yeah, just say main, that's fine. You will automatically attach .fxml. So finish, and then you decide what kind of a container you want. So the root element right now is anchor, and then you could have a border pane, flow main, grid pane, HBox or VBox, you know, whatever you want. So we can use, say, anchor pane, okay? And then we just say finish. If you want a border pane, you can do that as well. So there is the HTML fxml file. The reason I want to talk about this is because this is so important. The Android applications use XML. See, Android uses XML, but JavaFX use fxml. It's very similar. And even Microsoft, when they develop applications, use XML a lot. So that's why this is so much, so similar to the current industry. Okay, everywhere people use that. So that's why it's a good idea to have. You see there's a bunch of tags, right? See? This is the place you can get an anchor pane from this location. And this is the anchor pane we choose as a root. See, it's a tag. See, just like, you know, open tag name, and this is the attributes. And then you have closing tag, the slash, /. Okay, so now you can code right here. You can write the buttons, text fields, and tables, whatever you want. But there's a scene builder. You're gonna download, install it. Once you download, install it, you have to go to, in my case, Windows, I think is preference. Yeah, and then go to JavaFX. You click on JavaFX, then you open up JavaFX scene builder executable. Over there, you browse and then locate where the scene builder is installed. When you install it, you browse, I installed into Java myself. No, I installed into program files, and under program files, I put it down. There's a sim builder folder. Here you go. See sim builder folder. So I open sim builder folder. If you look carefully, there is a application called a sim builder. Okay, one says application, the other one says icon. So use the one that says application. That's the one. Then you say open. That's it. So now you're linking your Eclipse to sim builder. You link them. Okay. Once you link them, you can just say apply, and then apply and close. And now you are ready to edit this file, to add stuff into it, to add all the controls or the containers into it. So to do it, you open this view. Remember, I have a main XML created earlier. So I'm going to right click on this and just open with the sim builder. Okay. So now sim builder is attached to this file. See? There's nothing in it. All it has the anchor pane, right? You see the anchor pane? I don't even see it, and I can make it a little bit bigger. So when I highlight anchor pane, you go to anchor pane layout, okay? And then you can see this is the computer to the size. Let me see. It should give you position, rotate, scale, layout of bounds local. Okay, I don't see the place you can. Okay, preferred width, that's a place. So you can enter preferred width, and then here I want it to be say 400. Preferred height, I want to be 400. Then you say okay. Now you see your anchor pane, and that's where you can put your controls. Okay, now here are the controls. See, all the buttons, all these things, checkbox, choice box, color picker, combo box, so on and so forth. But I would like to put into a container first. So I go to container. Under container, I have. Can I move this down? That's kind of weird. I don't know how can. So you have accordion, anchor pane, you have a border pane, you have dialog. So on and so forth. You can put whatever you want. Grid pane if you want, HBox if you want, pane if you want, scroll pane. So everything, whatever you want. But I can just add stuff to it. So I'll go to control. I can add a button. See, there's a button. So I can add a button. I can drag it, put in any way I want. There you go, right? And then I can change what's on that button. So there you go. So right now it says button. See the text? It says button. I can say hello. Okay. So now you have hello on this button, and you can make it bigger, make it smaller. You can move it around, and that's much easier than when you code it the traditional way. Okay, you can have as many as you like, and you can also have a text field. So let's look for a text field. There you go. So text field. So drag a text field. You can put it over here. Okay. So now we're going to save. I have a button. I have a text field, right? So I can save it. File, save. Okay. I save. Now go back to my Eclipse. Go back to Eclipse and to click here. You see, whatever I added before, added a button. This is the size, this is the location, and this is the height, and this is the text field, where it's located, and what's on the button says hello. So you can do this fairly simply. Okay. So once you have that, you go to controller to generate another class. You go to main controller. Okay, the main controller, say finish, and then you can have add fxml. Okay, it's the annotation. add XML. Then you say there's a button, right? You say button, high-low button, okay? Then add XML. Then you have text field, and it'll say data field. Okay, so these going to be I'm going to import this. Okay, import a button as well. Make sure to choose JavaFX. Import text field as well. Make sure you choose text the JavaFX as well. Okay, so now that's so those two things are going to be linked to the to the thing on Scene Builder. Okay, so now we're gonna save this. We're gonna save this. Now I'm going to go to Scene Builder. Okay, go to Scene Builder. I don't think we have time, but okay. So now I just gonna finish this off before I go do that. So private, I'm gonna say get data, and then I'm going to do something called private void. Okay, retrieve data. Then nothing here. Then I just put it down action event. Make sure you do that. So just the event. So that has to be the same every time. Action event. You can import JavaFX. Okay, so you're gonna say you're gonna get the date one, so data field. So we're gonna call this a string data equals data field dot get text. Okay, so when you the get data is executed, then the data will be retrieved from text field, and then you say data field dot clear. So you clear that. That's it. So that's data field clear. So you can display it if you want to. So sys out data. Okay, so that's right. So I'm going to save this. Once I save this, then I can, or I can just say something. Data entered is data. All right. So I'm going to save this. Now I just go back to my here. Okay, and then hopefully I can add the controller now. Okay, so go to controller. I don't have the controller yet. Okay, so I may need to refresh it, or I have to refresh the other one. I don't know. Sometimes let me do here. I save this, right? Save it, refresh. If comes the worst, what you do is controller. Is it here? No, it's not here yet. So I'm going to close this, and then reopen that file. I know that one always works. Open with the Scene Builder. Okay, now the controller should be here. What happened? Why? It should show up here. Did I finish? Maybe I didn't. Hold on. Over here, controller. I don't think I need anything else.
Don't you think like maybe you have to link the controller package to that file that you're opening? Because you're opening the main fxml file, right?
Right.
So
But But yeah, that I know that's the case. Yeah. So I wonder how I can access this. Right. So open. How can I tell?
Import the controller package into the main fxml file somehow.
May import this into where? Into here?
Yeah, I'm not 100% sure how.
No, I don't think so. There's a little thing I forgot then where it is. Where it is. There's a thing you have to indicate where to find the controller. Controller class. Because it doesn't know
Next to the text field on controller class, there's like a little gear.
where. Where?
Like when you scroll over controller class, a little gear shows up next to the text field.
Controller class.
Down, and
Here?
then maybe you can click on that and link with that. Oh,
No.
no.
Mm-mm. No. That's interesting. I forgot where to specify which folder. It doesn't know that the controller folder. That's what happens. If you put them in the same folder, then you won't have the problem. I'm gonna have to tell you on Piazza. Okay, I will tell you in Piazza. So basically, this will show up. Then you have to link the text field and the button from the side. Then I will show you, and then I can upload this once I set it up onto GitHub. You can download and you can look at it. Just pay attention. On this side, there is a code part. That's where right now there's no code. So we'll show you how that's linked. This is the on action. This button is a click. What do you want to do? Basically, just enter that method in the controller. That get data, that action, that method will show up in here. Okay. So so right now I don't have a controller set up. I need to be able to access the controller. Okay, so I will do that. I know it's late, 20 minutes late. So I was trying to set up so you can spend some time on this project during the weekend. But yeah, I'm gonna upload it, and then if you need some help, if you are doing this, getting into difficulty, send me an email. We can talk it on the chat room like this. Face to face. I can show you how to do it if you get confused. Okay, there's so much to do. You can also have multiple scenes, multiple stages. So so we'll take some time to cover that. All right. So see if you can get the scene builder set it up at least, and then we'll cover the rest next time. Okay, I'm gonna write up some tasks for you to do. Something. Okay. I'm sorry it took me so long. I'll see you next week. Okay, bye.
Good day, weekend. Good day, weekend. Have a great weekend.